Here we have a SAT math problem. Okay, let's go to the question. 2x cube negative 6x square negative kx positive 3k equals to 0. In the equation above, k is a constant. For which of the following values of k, there are three different integer solutions for the above equation. Okay, in this equation, x is a variable. Actually, the solution is nothing but the value of x. That is, in this equation, we have three different integer values for x. And according to that, we have to find the value of k in the given answer choices. Okay, now let's solve this cubic equation we have over here. That is 2x to the third power negative 6x square negative kx positive 3k equals to 0. Okay, now let's try to factor the expression we have on the left side of the equation. When I consider the first term and second term, the greatest common divisor is 2x square. That is both 2x cube and 6x square are evenly divisible by 2x square. So we can factor 2x square. When 2x square is factored out, to get the stuff inside the parenthesis, we have to divide the first term and the second term by the one I factored, that is 2x square. When I divide this 2x cube by this 2x square, I'm just getting x. When I divide this negative 6x square by this 2x square, I am getting negative 3. Okay, even if I distribute this one to this and this, I must be getting these two terms. When I multiply 2x square and x, I am getting 2x cube. When I multiply 2x square and negative 3, I am getting negative 6x square. And the greatest common divisor for this one and this one is k. But here, this term is having a negative sign, so we can factor negative k out. Then I am getting x negative 3 inside the parenthesis. Okay, now let's verify the factoring what we have done. When I distribute this negative k to this x, I am getting negative kx. When I distribute this negative k to this negative 3, so negative times negative will become positive. K times 3 is 3k. And we can write 0 on the right side. Okay, now the greatest common divisor for this one and this one is clearly x negative 3. So we can factor x negative 3 out. When x negative 3 is factored out, we are left with 2x square in the first term and negative k in the second term. So we get 2x square negative k inside the parenthesis over here equals to 0. Okay, here the product of two quantities equals to 0. Whenever the product of two quantities equals to 0, the first one may be 0 or the second one may be 0 or both of them may be 0. So that is the first one, x negative 3 may be 0, or the second one, 2x square negative k equals to 0. Okay, if I solve for x in this one, I'm getting x equals to 3. That is, we have to add 3 to both sides to solve for x. Negative 3 positive 3 will cancel. I'm getting x equals to 3. Okay, so according to the question, we have three different integer solutions. In those three different integer solutions, now I got one of the integer solutions, that is 3. So we'll be getting two more different integer solutions from this equation, 2x square negative k equals to 0. Okay, so let's solve for x in this equation. For that, we have to add k to both sides. When I do so, here negative k positive k will cancel. I'm getting 2x square equals to k. Okay, let me continue solving the equation over here. 2x square equals to k. Okay, let me divide both sides of this equation by 2. When I do so, this 2 will cancel out. I'm getting x square equals to k over 2. Now, to get rid of the square we have for x, what I have to do is I have to take square root on both sides. Then this square root and square will cancel out. And for the square root on the right side, usually consider positive or negative sign. So here on the left side, we get x, and on the right side, we have positive or negative square root of k over 2. Okay, here we have two more solutions. That is, already we got one of the solutions, that is 3 for the given equation, and we have two more solutions over here. That is, x equals to positive square root of k over 2 is one solution, and x equals to negative square root of k over 2 is another solution. Okay, now, so there must be three different integer solutions, and already we got one integer solution. So these two solutions must be integer solutions. I mean, the value of this square root of k over 2 and the value of this negative square root of k over 2 must be integers. According to that, we have to find the value of k in the given answer choices. Okay, now what we can do is we can verify the given answer choices one by one. That is, let me consider the value 0 for k in the answer choice A. Okay, now let me plug in this 0 for k to this one and this one. What will happen? Okay, let me continue over here. Okay, when I plug in k equals to 0, then I am getting, when I plug in k is equal to 0, 0 over here, 0 divided by 2 is 0, square root of 0 is still 0. And when I plug in k equals to 0 here, the same thing, 0 divided by 2 is 0, square root of 0 is 0. Okay, here we get the same solution. So that is, we get only two solutions for the given equation when k is equal to 0. One is 3 and the other one is 0. But both of them are integer solutions, but we get only two integer solutions. Okay, according to the question, we must be getting three different integer solutions. When I take k equals to 0 in answer choice A, I am getting only two different integer solutions. So we can reject the value of k in answer choice A. Okay, now let me consider answer choice B, that is we have k equals to 1. Okay, now let me plug in 1 for k over here, then we get x equals to square root of 1 over 2, and here x equals to negative square root of 1 over 2, then we get x equals to, here we have square root for a fraction, so then what we can do is we can take square root for numerator and square root for denominator. Okay, then we get x equals to square root of 1 is 1 divided by square root of 2. So when I solve for, when I evaluate the value of this one, the same thing I'll be getting with the negative sign, that is negative 1 over square root of 2. Anyways, it is not integer, and this one is also not an integer, because we know that square root of 2 as an irrational number. When I divide this 1 by this irrational number square root of 2, still I'll be getting an irrational number. So I don't get integer solution over here and here. So when I consider the value 1 for k in answer choice B, I don't get three integer solutions for the given equation. So we can reject answer choice B as well. Okay, now we can consider the value 4 in answer choice C. For k, let me plug in 4 for k over here, then I'm getting x equals to square root of 4 over 2, and here x equals to negative square root of 4 over 2. We get x equals to square root of 4 over 2 is 2, and here x equals to negative square root of 2. Again, I don't get integer solutions because square root of 2 is an irrational number, and this one is also negative square root of 2 also is an irrational number. So when I take k is equal to 4 in answer choice C, I don't get three integer solutions for the given equation. Okay, now let me reject answer choice C. Okay, now let me consider the value 8 in answer choice D. Let me plug in this 8 for k. Then I'm getting x equals to square root of 8 over 2, and here x equals to negative square root of 8 over 2. Here x equals to square root of 8 over 2 is square root of 4, and here x equals to negative square root of 4. We know that square root of 4 equals to 2, and here we get x equals to negative, the square root of 4 is 2. Okay, when I take the value 8 for k in answer choice D, I am getting three integer solutions for the given equation. The first solution is 3, and here this 2 is the second solution, this negative 2 is the third solution. All these three values, 3, 2, negative 2, all of them are integers. So when k equals to 8, I am getting three integer solutions for the above equation. So the value of k is 8. We get that 8 in answer choice D. The correct answer choice for this question is D.